right, you guys go ahead and put the title, pause this, put the title in your table of contents, make sure you're all set up to take your notes, using general quadratic form to model a projectile. And on this assignment in Schoology, there should also be a link with all of these questions on there. This is the first question, and I'm going to use it to do a little example problem here. A ball is thrown straight up from the top of a 64-foot building with an initial speed of 48 feet per second. The height of the ball as a function of time can be modeled by the function h of t equals negative 16t squared. This should be squared here, it just came out funny. T squared, so we know it's a quadratic, plus 48t plus 64. So let's take a look. First of all, we know that our general form is y equals ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of just the x, and c is the constant that does not have a variable attached to it. This may be freaking some of you guys out, this h of t. That just means height at a given time. So instead of y, they use what is the height. Okay, so we know that on the y-axis is going to be height at any given time, t. Okay, and then that's why they use t in the actual formula. So projectiles in general formula, it's a great thing to use because if we take a look at this, let's write down what is our a in this situation. It's negative 16. Just negative 16. That t squared is actually not part of the a, it's just the coefficient. Our b is 48. And our c is 64. In a projectile, like if you're throwing a ball, if there is like a missile, a plane, anything that makes this kind of shape, a parabola shape where it goes up and down, at a certain speed is going to be set up like this. Negative 16, and that's in this case feet per second squared, this is gravity. Okay, so our a, whenever we're talking about projectiles, is going to be the gravity. So that number is not going to change because gravity is kind of fixed. It'll only change if you use different units. Like I think if it's meters instead of feet, it's negative 9.8. Okay, 48, that's the speed of the object. And 64, this is the initial height of the object. Okay, and I know because it's negative 16, it's going to be a negative, and that means both ends of my parabola point down. It's a negative parabola, and all projectiles are going to be this way, where both sides point down, so they're always going to have that negative gravity being negative right there. If I were to go ahead and draw, if this was a graph, I would draw it. It would look like this because this is going to be, my y-intercept is going to be 64. And c is always your y-intercept. In a projectile situation, it's always your initial height. But c is always your y-intercept. And I think I've talked about that before. Okay, so this point here, our y-intercept is going to be 64 feet. Okay, we're going to have a maximum number here. Okay, and then this, where our height is 0 again, this is where it hits the ground. So that's really important to know because if the ground is 0 and I know that height is y, I'm going to rewrite the equation it gave us, and instead of being height of time t, or y equals, how they have negative 16t squared, blah, 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 I'm going to put 0 equals negative 16t squared plus 48t plus 64. Okay, so I need to figure out what value of t will make this 0. Well, this one, luckily enough, we can factor it. And then let's do that for this video. We'll factor it and solve it. And then on the next way, I'll give you a couple of different options for solving these. One using the calculator and quadratic formula, and even completing the square. But for right now, we can factor this. It's equal to 0, but my a is not equal to 1. So I can divide everything by -16. And I know this is going to work because 48 and 64 are both divisible by 16. So I'm going to divide everything by -16, even the 0, but remember that just stays 0. So I have now 0 equals t squared minus 3t minus 4. So I'm looking for two numbers that add up to be -3 and multiply together to be -4. And I think that's -4 and +1. -4 times 1 is -4, and -4 plus 1 is -3. So 0 is equal to x plus 1 and x minus 4. So I factored it. I still need to solve it. So x plus 1, how do I make, what number can I put x in here to be 0? That's going to be -1, because -1 plus 1 is 0. And what number can I put here to make this 0? That's going to be +4, because, and that's going to be my second root here, because 4 minus 4 is 0. So I know that where it crosses here, remember there's two solutions to a quadratic, possibly two solutions. That's going to be -1, because that's one of my roots. And I know over here this is going to be +4. -1 seconds, that doesn't mean anything. So actually in this real world situation, this has no meaning. So by default, I know that the correct answer, even though there's two answers to this equation, the correct answer is going to be +4. So if we're answering a complete sentence, will take 4 seconds. Whoops. It will take 4, it's a funny seconds, for the ball, sorry you guys, ball to hit the ground. Okay, and now that I know those roots, I know a couple of other things, like what number is directly in between -1 and 4. We can always find the average. -1 plus 4 divided by 2 is going to be +3 divided by 2 is going to be 1.5. Okay, so that means my line of symmetry right here is x is equal to 1.5. Okay, and now that I know x is equal to 1.5 here, I can figure out what my maximum point is by putting that back into the equation. So if I solve this equation for y this time, for my height, if y equals -16 times 1.5 squared plus 48 times 1.5, everywhere I see an x, instead I'm going to put 1.5, plus 64. If I type that into the calculator just like that, and I'm going to do it, pause it, and be right back. I'm back. Look at the calculator. So I typed it in just like I wrote it. -16 equals 100. So at 1.5 seconds, it has reached a maximum height of 100 feet and then started to come back down. So I've actually answered quite a bit of information here, right? I'm going to go ahead, we're at about 10 minutes here, but I'm going to come back with another video and we're going to talk about what if I had completed the square to do this. If I could have used the calculator to graph it and do this, I'll do another example problem. And then I'm going to ask you to try some of the problems on your own that are attached to this assignment.